Very good morning, children. Class 11 children, today let us see system of particles and rigid bodies. So in this lesson, what are we going to discuss about? What is the learning outcome of this lesson? Number one, you are going to learn about what do you mean by rigid body and what is actually the system of particles. And secondly, we are going to learn about center of mass of the system. Why is it very important, the center of mass of the system? The whole world and the universe, every particle around us, it is based on the concept of center of mass only. So what we are going to learn is just the basic of it. And the different types of motion, the acts of rotation, and the terminology called as moment of inertia. We learnt about the inertia of a body, that is for the linear motion. Now in this lesson we are mainly going to discuss about the rotational motion, the angular momentum, the conservation of angular momentum and certain application of angular momentum. So these are the learning outcomes. So come, let us learn about the system of particles and rigid bodies. So first, what do you mean by a particle? A particle is nothing but, for example, when you take an object, this is an object, it is made up of collection of large number of particles internally. The particles are considered to have a point mass, small mass. What do you mean by small mass? The distance, for example, point object, sun is a point object because the sun is far away distance from us, therefore it is considered to be point object. Just a relative term called point object. Similarly, these particles inside are distributed in the rigid body, that means in this body. So this particle is nothing but object of mass is finite and internal structure can be neglected. What do you mean by system? It is a collection of very large number of particles which mutually interact with one another. Now, rigid bodies, ideally speaking, there is no body called rigid, that means there is no such body, does not even undergo deformation, does not undergo some slight dislocation on application of external force. But some dislocations or some deformation can be neglected if it is going to be very small when it compared to its size or the distance from the other particles. So ideally, rigid body is a body with perfectly definite and unchanging shape. The distance between all pairs of particles of such body does not change. So this is how the rigid body can be defined. You don't call that every body should have a definite shape like a sphere or a cylinder or cone. That's also a rigid body, but doesn't mean that only regular shape has got rigid body. Can have any shape. So such rigid body I have taken, there are a lot of particles present, M1, M2, M3, etc. All these particles, the distance are going to be remaining the same. So that is called as rigid body. Now let us learn different types of motion. The number one is translation motion, that is nothing but linear motion. Linear motion. So the linear motion, the particles on object can be linearly can move or linearly it can be sliding, and here also the ring can slide without rolling. So in all this linear motion, all this internal particle which is present also move with the same velocity as the system. So all this will be moving at the same velocity of the system. So translation motion, linear motion we know. Now coming to the rotational motion. So I have taken a rigid body, many particles are present, M1, M2, M3, M4 like that. All the particles are also undergoing the rotational motion if the whole system is going to rotate. So for example, the whole system is rotating, inside the particles also will undergo rotational motion, but describing the circumference of the circle of radius R1, R2, etc., because it depends upon the position. So with respect to this axis of rotation, all this particle will be undergoing a circular motion along the circumference of circle around its axis, therefore a radius changes. But if you consider one such particle exactly at the center of axis of rotation, then the particle will not move, therefore its velocity is 0. All other particles will have velocity v1, v2, etc. depending upon the distance from the axis. So, we learn rotational, we learn linear motion. There is another kind of motion in which you must have noticed that this is spinning top, top. So, the spinning top in which once after you spinning and then you start it on the surface on the ground, the spinning top has the fixed point. Around the fixed point what happens? The top axis will be keep on moving. So, hither and thither the top axis will be keep on moving over here. So, therefore, this kind of motion of the top in which the point O is fixed whereas the axis is different. So, that is called as precession. So, the point of contact of the top of the ground is fixed whereas the axis is changing. One such and more example, axis of rotation for the blades of a table fan or pedestal fan. So, the axis of rotation, one point O is fixed whereas the axis is completely varying. So, all this kind of motion we have seen. Now, let us see about the center of mass of all particles. Now, I am going to consider a rod. So, the rod, I am considering two such particles of the rod, M1 and M2 on both the sides. So, this is the rod. I am considering two such particles, here one particle, here one particle. These two particles, right, at the end, whereas exactly where is the center of mass lies, center of mass is nothing but the particles where whole of the mass is supposed to be concentrated, balance point, that is called center of mass. Center of mass is nothing but the balance point. For example, if I take this, the center of mass is exactly the center, that is a balance point. So, if I take this is the center of mass, that is a balance point. Center of mass may shift. For example, for us, center of mass, when I am sitting, the center of mass has come down. When I am standing, the center of mass would have been raised. Where supposed to be concentrated, then only you can have a balance. The mass distribution balance we are looking at. When you are lifting the heavy object also, in order to place it on your head, where you have to place it? Exactly the center. One corner, if you place it, what will happen? It will slide down. So, therefore, I am taking a rod in which considering two particles M1 and M2. After considering two particles, now you apply a force at the lower part of this two particles, that means lower part of the rod. When you apply a force at the lower part of the rod, what will happen? It rotates in the anti-clockwise direction. When you apply a force at the upper part of the rod, it rotates in the clockwise direction. Whereas when you apply a force exactly at the center of mass, middle part, no rotation, only linear motion. That is a concept. So, hope you understand this center of mass. So, what is center of mass of the system? It is a point where whole of the mass of the system are supposed to be concentrated, and the point like mass has the same type of the translational motion as the system. However, the system is moving, the particles also will be moving. So, hope you understand now center of mass of the system of its two particle system. So, center of mass of a body of two particle system. So, center of mass of a body or system is its balancing point, we know. So, let us take two particle system. Balancing point is the center of mass. So, consider two such particles M1 and M2 whose position vector is R1 vector and R2 vector. So, therefore, for these two particles of mass at the center of mass, let us suppose it is somewhere in the middle. If it is going to be same mass, it where in the middle, or if it is going to be heavier mass towards heavier mass, it will be. So, center of mass. So, it can be expressed as RCM vector is equal to position vector M1 R1 vector plus M2 R2 vector divided by M1 plus M2. What if it is going to be a n particle system? N particle system M1 R1 vector, M2 R2 vector, etc. Mn Rn vector divided by M1 plus M2 plus etc. If you consider all the masses almost equal, then you can take simply m. So, sigma I is equal to 1 to n mi ri vector. So, that is the center of mass position for all the masses n particle system. So, one such example let us take here. Find the center of mass of the 4 particle system. Where is the 4 particle present? At A, B, C, D. So, let us take the 4 particles are distributed, or I am going to fixed frame of reference, x axis and y axis. So, along x axis for A mass it is 0, 0, and for B mass it is 1, 0, for C mass it is 1, 1, D mass it is 0, 1. So, therefore, I wanted to find out center of mass along x axis you find out. Along x axis directly use the same formula. So, same formula I am going to use. RCM along x axis is equal to m1 x1 plus m2 x2 plus m3 x3 plus m4 x4. Why I am taking 4? Because 4 mass is there, divided by all the 4 mass, m plus 2m plus 3m plus 4m. So, that will be equal to, therefore, m into x1 is 0 plus m2 is 2m into, what is x for 2m? So, that is 1 meter plus 3m into what is x3 over here 1 meter plus 4m into x4 over here, that is 0, divided by 4 plus 3 7, 7 plus 1 8, 8 plus 2 10m. So, therefore, what happened? This is 0, this is 0. So, 2m plus 3m is equal to 5m. 5m divided by 10m, so that is equal to 1 by 2. So, RCM is nothing but exactly 1 by 2 meter. So, 1 by 2 meter along x axis 0.5. Similarly, RCM along y axis you find out. Same way, same formula, but instead of x, y axis. So, that will be equal to RCM is equal to y axis. So, m into y1, m1 y1 plus m2 y2 plus etc., that is etc. is nothing but m3 y3 plus m4 y4 divided by m plus 2m plus 3m plus 4m. So, that will be equal to, what is m1 y1? 0. What is m2 y2? 2m into 1, 0, got it, and 3m into 1, but 4m into 1 divided by 10m. So, this is 0, this is 0, 3 plus 4, how much is that? 3m plus 3m into 1. You can see here 3m into 1, 3m into 1, 4m into y axis la 1. So, therefore, you get exactly 7 by 10. So, that is equal to 0.7 meter. Along x axis, yeah. So, along x axis m1 x1, you can see m1 into 0 plus m2 2m into x and 3m into 1 4m into 0. So, you get 1 by 2 meter along x axis, but along y axis what you get? Along y axis we get 0.7 meter. So, 1 by 2 meter along x axis and 0.7 meter along what axis? Y axis over here. So, 0.7 meter along y axis, it will be here, somewhere here. Okay. So, the center of mass it lies at x axis 0.5 and y axis 0.7 meter because of the difference in mass. If it is exactly same mass, exactly in the middle point it will lie 0.5 and 0.5 because of the difference in mass m, 2m, 3m, 4m. So, therefore, the center of mass slightly shifted up. So, hope you understand this question. So, now let us go to the next topic, that is torque. So, let us go to the next topic called as torque rotational motion, torque and angular momentum. So, these are the topic, very important topic. So, let us go to the torque and angular momentum. And beforehand, I want you to learn the center of mass of certain rigid bodies, that you can always learn. As well, you also need to know about the motion of the center of mass. So, let us see that motion of the center of mass and then come back here. Motion of the center of mass. Motion of center of mass. Okay, so I will just show you that motion of the center of mass in the NCERT textbook. Yeah. You can see here motion of the center of mass. So, this is actually a rolling motion. You can see here solid cylinder is rolling, cube, everything is rolling here. Same mass and same size. Can you see? Even though same mass and same size, all are not, reaching at the same time. So, it is a different. So, why is it different? There is a terminology called as moment of inertia that we are going to see. Now, the rotational motion, I was talking about the rod, all that. So, I was talking about the rigid body, the same thing here. So, this is the rigid body, but you have n number of particles here. So, distance between the 2 points is remains constant. So, external force is acting on the rigid body, but still the distance between the body remain constant. You can see the distance between the 2 points remain fixed. So, even if it is going to be moving, the distance between the 2 particles does not even change, therefore, it is called as rigid body. Now, let us see about the linear and translational motion. So, this is the linear motion, or you are pulling or pushing the block. So, even though you pull or push, the distance between the 2 particles inside this rigid body does not change. Therefore, you can say that the body rotates around its fixed axis. Next one, rotational motion. So, you can see that axis and the body is moving. So, same way here, even though the whole body is moving here, each and every particle position is not changing. Every point has the same angular velocity and angular acceleration. So, it is going to be rotating here. So, even though it is going to be rotating here, the each and every particle distance, every particle will be moving along the circumference of a circle, but the distance of separation does not even change. Now, you can see here, this is a linear motion as well as rotational motion. Look at the center of mass. Common center of mass does not even change. This angular force, you call it as torque over here, which is equivalent to rotational equivalent of force. See, you can see the spinning fan. The turning effect of force, you call it as torque. You can see here, the person is going to push the door. Where? Exactly away from the axis. So, he is able to open it. angular force, you have to give a force, and also it matters the location of the force. So you can see here, this is the door, and along x axis the distance, and this is along y axis. So now you see how to give the force. You can see the axis of rotation of the force. So where are you giving the force? You can see that. And the hinges of the doors, are you giving the force, are away from that. So we are giving the force away from it. So therefore it opens. So for example, if you take the opening box like that. So I am taking an opening box like that. So now this is axis. So if I am going to open it by just giving the force along the axis, it doesn't even open. So but then if I am going to give the force exactly away from it, so exactly away from it, then it will open. So that is how this every door along the hinges, if you are going to give the force, it doesn't even open. Away from the hinges of the doors, perpendicular to it, if you give the force, so what happens? It opens. So you can see the same here. So you can see here, this is the force, and this force perpendicular to this force, the radius vector is going to be, that is nothing but the distance from the axis of rotation to the point where the force is applied. So this is the axis of the rotation, that means the hinges of the doors. So hinges of the doors, away from the hinges of the doors at a distance r, you are giving a force. So therefore the door is able to open it. So you can see here, we say torque, it is called as torque. The rotational motion, you call it as torque. So you can see here the force is acting at an angle theta from the radius vector. Yeah, can you see here the force is applied along the direction of the force, along the axis, there is no, but perpendicular to it, if you are going to apply, then there will be a rotational effect. You can see here. So R and F should be perpendicular, then only clockwise and anti-clockwise the rotation is going to be. So therefore the torque is represented as perpendicular force into distance from the axis of rotation, therefore R cross F. So this is R cross F sin theta, because he is giving a force which is perpendicular to the axis of rotation. So hope you understand, children. So now let us go to this NCERT textbook. You will have a better understanding. Yeah. Yes. So now we were talking about the precision, the spinning top, table fan. So now this is actually the particles undergoing rotational motion. The particle is undergoing rotational motion here. Since the particles are undergoing rotational motion with a different radius, you can say that all the particles will have different velocity inside the rigid body. Now, we were talking about the motion of the center of mass, motion of the rigid body, which is purely translation. So you can see that since it is purely translation over here, you can see here, in this case, the point O position and the P position, both are acquiring the same angle over here. There is no angular shift. This is for rigid body, which is purely translation. And what about the rigid body, which is a combination of translation and rotational motion? You can see here the combination of translation and rotational motion. The O and P is not acting as the same angle. So, the O and P is at different angles. So, therefore, you can say during the translation motion, the point O and the point P both are in the same line. It is fixed, whereas whenever it is a rotational motion, it makes an angle over here. So, that you have to take into account. So, now we will just go to the next point here. So, these are the examples of a certain rigid body. So, now let us talk about the motion of a center of mass of a rigid body. The motion of a center of mass of a rigid body, what does it says here? We know that this is a system of particles. So, M1, M2, M3 etc. There are a lot of particles that is distributed in the rigid body, and from the axis, from the origin, let us take R1 vector and this is R2 vector over here. Now, I am going to give an external force for this. So, when external force F is applied, when external force F is applied, then you can say that all the particles will undergo acceleration, that is m into a vector. So, therefore, the net external force will be equal to the total mass into m total into this acceleration, net acceleration over here. So, F is vector quantity, therefore, acceleration is also equal to the vector quantity here. So, now what is the center of mass of the particle whenever it is moving? When center of mass of the particle moving, the whole particles also is said to be moving. If F net is equal to 0, when F net is equal to 0, then you can say that m into a will be equal to 0, or you can say that acceleration is also equal to what? 0. So, therefore, you can't say that acceleration is 0 means rate of change of momentum is equal to 0. So, therefore, d by dt of mv is equal to 0 over here. So, if acceleration is 0, v is not equal to 0. So, therefore, v is equal to what? Constant. That is called the motion of the center of mass. So, now you can say here the linear momentum p is equal to constant. So, therefore, you can say v center of mass is equal to constant over here. So, therefore, you can say center of mass moves with constant velocity. Center of mass moves with constant velocity, or otherwise a system interacting internally cannot accelerate itself. A system interacting internally cannot accelerate itself. But for example, I am going to take, I am taking one nucleus. X is the nucleus, atomic number is Z, A is the mass number. So, now this is moving with velocity v. So, when it is moving with velocity v during its motion, it is undergoing a radioactive decay. Radioactive decay. So, this radioactive decay is only due to the internal forces. So, since it is internal forces or due to the internal forces, the total momentum remains constant. So, therefore, this is getting splitted up into this radioactive nucleus there, no. So, when it is undergoing decay, because it is unstable, therefore, it has to undergo decay. While it is undergoing decay, what will happen? It is split into two fragments. So, for example, this is alpha particle, radioactive nucleus is giving, let us suppose it is alpha particle helium. Another particle it is giving, so this is Y particle it is giving. So, it is splitting with some other particle, but though it is splitting with a different particle, this nucleus, that is alpha, this radioactive nucleus still its motion will be along its center of mass. the still its motion will be along its center of mass. It moves along the direction of the center of mass. So, it does not, even though it gives you a scattered particles like alpha particle and other one some other nucleus, but the motion is still along its center of mass. Whereas when you take the nuclei at rest, nuclei is at rest, parent nuclei is at rest. So, if it is going to be at rest, what will happen? How does it decay? The earlier whatever you have seen, it is moving. The moving nucleus, while it is disintegrating, it split into parts, alpha particle and other nuclei. But though it is splitting into parts, the parent nuclei is there, no. The parent nuclei move along its center of mass. Whereas, if the nucleus is at rest, parent nuclei is at rest. So, what happens? At rest and then it is disintegrating. When it is at rest and disintegrating, it disintegrates into equal parts in the opposite direction. So, in the opposite direction, so here light nuclei will be splitting over here and heavy nuclei, for example, here alpha particle and here another nuclei will come here. So, this is the Y, ZA will come here. So, what is the difference between the previous one and this one? Previous one, while it is moving, it is disintegrating into different parts, scattered into different parts, but then the center of mass, it moves along with the center of mass motion, center of mass direction. Whereas here, if the nucleus is at rest, what happens? It split up into two different direction. Two different direction means what? Only in the opposite direction. Whereas here, it's split up into different fragments in any direction. It can make an angle theta. Whereas this one, it is 180 degree in opposite direction. Lighter nuclei this side and heavier nuclei this side over here, if the nucleus is considered to be constant here. So, same way, whenever you consider the expression for the projectile, so let me show you that projectile from the NCERT textbook here. You can see here, projectile while it is exploding. So, if even though it is undergoing a parabolic path, the path of the center of mass of the fragment still in the same direction. See, it is a good illustration. You can just read out this from the textbook. Here, a projectile following the usual parabolic trajectory explodes into fragments in the midway air. The forces leading to the explosion are internal forces. They contribute nothing to the motion of the center of mass. The total external forcing, that is the force of gravity acting on the body, is same before and after the explosion. Therefore, the center of mass under the influence of the external force continues therefore along the same parabolic trajectory as it was followed if there are no explosion. So, hope you understand. So, what does it means? The center of mass of the fragments of the projectile continues along the same parabolic path which it would have followed if there were no explosion. So, even if there is no explosion, it will be following a parabolic path because the one and only force which is acting is force of gravity. But though it is going to explode, the center of mass motion, the path of the center of mass of the fragments remain the same. So, that is what is meant to say. Here you can see that the center of mass of the radium that is splitting up into two, helium and another radon, but the motion of the center of mass still along its same path. And heavy nucleus radium split up into lighter nuclei and radon and an alpha particle, center mass of system is in uniform motion. Whereas if it is at rest, the same splitting of the heavy nucleus radium, the center of mass at rest, the two product particles fly back to back. So, this is an example, children. So, hope you understand. So, now let us see the definition of the vector product, which I have just shown you one animated video. So, now let us see torque and angular momentum. So, before that, do you know angular velocity? Do you know angular velocity? Angular velocity. What is it? Angular velocity is nothing but, it is the angular velocity is nothing but rate of change of angular displacement, or you can say angular displacement by time taken. So, I am going to consider one such rigid body. I have already told you rigid body does not mean that it should have definite shape. It is rotating with an angular velocity omega. So, each and every particles will be undergoing a circular motion, circular path, that is radius r1 with velocity v1, and m1 in m2 is at distance far away. So, this m2 will be moving at the velocity v2, but one which is exactly the center does not have any linear motion because the velocity is going to be 0. So, now therefore, all these are undergoing an angular displacement. Hence, you can say that if delta theta is the angular displacement, of the particle, angular displacement in delta t time. So, therefore, the angular displacement can be written as delta theta divided by delta t. For delta t tending to 0 over here, omega can be written as d theta by dt. So, the direction of the angular velocity is along the axis of the rotation. So, along the axis of rotation direction. So, therefore, it is a vector quantity, axis of rotation. So, now what is the relation between linear angular velocity? Linear and angular velocity in circular motion itself we have seen, no, that rotational, that is the same as that of in circular motion. Here also rotational motion, v is equal to r omega. V is a vector quantity, therefore, omega is also a vector quantity. So, now let us see angular acceleration and then come back to angular acceleration. So, the angular acceleration alpha is nothing but rate of change of velocity dv by dt. So, that is equal to d by dt of r omega. So, therefore, I can write it as alpha is equal to d omega by dt into r. So, therefore, alpha is equal to r into d omega by dt, or you can say dr by dt into omega over here. So, therefore, you can say that alpha is equal to a by r, therefore, a is equal to r alpha, okay, because what is dv by dt? dv by dt is nothing but r into d omega by dt. So, therefore, I can even write this, angular acceleration, differentiate both the sides, you will get it. So, instead of writing all that stuff, you can just differentiate this. You differentiate what you get dv by dt, that is equal to d omega by dt. So, this d omega by dt is nothing but r alpha, that is equal to what? Acceleration. So, a is equal to r alpha. So, that is the relation between linear acceleration and angular acceleration. Alpha is called as angular acceleration. So, now coming back to this torque. Torque is nothing but it is a rotational analog of force and linear momentum, So, now I am going to consider a rigid body. I do not need to just to definitely draw it. I am going to consider one such particle of the rigid body, that is point P. So, torque is going to acting on the particle P. This particle P whose position vector is r vector over here. It is going to act, if the particle P is going to be considered in xy axis. Let force F is going to be acting on the particle here. What angle I am going to apply the force? It is making an angle theta over here. Resolve into components. When you resolve into component, this is called f cos theta component and this is called f sin theta component over here. So, now this f sin theta component and the product of the f sin theta component and the position vector r from the origin alone is contributing torque. So, therefore, if a force F is acting on a particle, F acts on a particle at an angle theta with direction of the position vector, r vector, then the torque tau is equal to r cross F. So, which is nothing but tau is equal to rf sin theta, because I am writing multiplication of rf sin theta. Rf sin theta can be written as r cross F. How? Because already we have learnt what is A cross B, children? AB sin theta, right? Same way tau is equal to rf sin theta. It is a vector quantity. vector quantity, it has direction. SI unit of torque is joules. And dimensional formula ml square T power minus 2. The distance r sin theta. You can also write in terms of r sin theta on application of the force by extending it. So, how is that? A liter. So, same way here. So, this is origin and this is r vector and this is point P. Point P only I am going to apply a force. How am I applying a force? Like this. Now, extend this force and drop a perpendicular over here. So, after dropping a perpendicular over here, this is called as r sin theta component. So, when you take an r sin theta component, as because I have extended here, so therefore, the force into r sin theta component will constitute torque over here. So, either of the two way you can write it, where r sin theta component is called as lever arm or moment arm, lever arm, or you can call it as moment arm, moment arm. So, hope you understand this children. This is theta, this is also theta. So, this is how your teacher expect you to write F vector, R vector, position, this is x, y, all that you write. So, from this what can you understand? Torque is nothing but rotational force. Very simpler you can learn. Torque is a rotational force. So, whenever you take a body and then you rotate it, for example, here I am taking a pen and then you rotate it anti-clockwise direction, you require two force. Can you see that? Couple effect. So, I am rotating only with the two fingers. So, when I rotate with the two fingers anti-clockwise direction, it comes up. So, same way I will take another object. Here I am taking a water bottle. So, I am rotating is anti-clockwise. Look at that. So, I am taking anti-clockwise direction. So, torque is acting upwards. If I rotate two forces, two equal and opposite forces, couple effect. These two forces cannot meet, that means there will be a separated by a perpendicular distance. So, now I am rotating clockwise direction. So, therefore, torque is acting inverse. Therefore, couple effect will produce a turning effect that gives you a rotational force, that is called as torque. So, what is couple effect? Couple effect, couple effect, or you can say turning effect. The turning effect of force, turning effect. So, for example, two equal and opposite forces, this is force, this is force. So, these two forces are acting separated by a perpendicular distance over here, constitute torque effect. So, net force is equal to 0 over here, therefore, it gives you a turning effect. This is called translational equilibrium. Why it is called as translational equilibrium? Because it does not undergo any translatory motion, no translatory motion, no translatory motion, only turning effect, rotational motion. No translation motion, only rotational motion, therefore it is called translational equilibrium. Okay, what will it do for rotational equilibrium? Rotational equilibrium. For rotational equilibrium, apply a force on both the ends in the same direction of the force. Understand? So, same direction of the force with respect to the center of it is a D, and here also it is going to be D. Here this is called load and this is called load arm, and this is called effort, and this is called effort arm, effort arm. So, now this is under rotational equilibrium, no rotational equilibrium, no rotational equilibrium. Rotational equilibrium means no rotational effect, that is called no rotational effect. So, now F1 D1 is equal to F2 D2 is equal to F2 D2, that is nothing but load into load arm is equal to load into load arm is equal to effort into effort arm, effort into effort arm, effort arm. This is called as principle of moments. This is also called as principle of moments. or you can simply write F1 d1 is equal to F2 d2, or F1 by F2 is equal to d2 by d1, which can be called as mechanical advantage. Either you can write load into load arm is equal to effort into effort arm, or you can write F1 d1 is equal to F2 into d2. So, we have seen rotational equilibrium, we have also seen translational equilibrium. So, now the same way we are going to see angular momentum of rigid body, which is denoted by the symbol L. Same way how we have taken one point of the rigid body, so point P, which is the distance r1 from the axis of from the origin over here, this x axis, y axis. I am going to apply a force. So, instead of applying a force, I am saying that a small velocity has been given to it. So, small momentum has been given to this particle of mass m. So, this momentum P is acting at an angle theta over here. Same way, what did I do? Extend it and then you find out. So, this is r vector. So, this is called as r sin theta component. So, therefore, angular momentum is defined as the product of linear momentum P and perpendicular distance from the axis of rotation. This is the axis of rotation of the rigid body. So, this is the axis of rotation of the rigid body. So, therefore, I can say that perpendicular distance from the axis of rotation, axis of rotation of the rigid body, axis of rotation of rigid body. I have already told you children, rigid body, the distance of separation between the particle does not even change. That remains the same. So, during its motion. Also, one more thing we have discussed already, if it is going to be a projectile motion, the body is projected with some external force, a gravitational force. The center of mass of the motion of the particle does not even change, even if it is going to be exploding in the mid-air. Same way here, the product of linear momentum and perpendicular distance from the axis of rotation of rigid body constitute angular momentum, which is L is equal to r cross P, which is nothing but Rp sin theta. That is angular momentum. So, I know torque, I know angular momentum. So, now let us see the relation between torque and angular momentum. What is the symbol of torque, children? Tau. What is the symbol of angular momentum? L. So, let us see the relation. We know that L is equal to R cross P. How do we know? Just now we saw. Is it a vector quantity? Yes, it is a vector quantity. You have not written. Can you write that? Vector quantity. What is the SI unit of angular momentum? This is kilogram meter square per second. What is the dimensional formula of angular momentum? R is L, P is what? Momentum. Momentum is mv, right? So, ml t power ml square t power minus 1. That is the dimensional formula. You can check the same. So, now relation between torque and angular momentum, differentiate with respect to time. You differentiate with respect to time. So, when you differentiate with respect to time, what you get? dl vector divided by dt vector, dt, not dt vector, dl vector by dt is equal to. Differentiate r cross p with respect to time, one after the other. Keep one constant and differentiate other one, and vice versa. dl vector by dt is equal to p dr by dt is nothing but p vector cross dr by dt. I am keeping p vector constant and then differentiating, plus r into dp by dt, r vector constant differentiating. P is nothing but mv vector, dr by dt is v vector. Children, recap this. What is I cross I? Cross product we have seen, no? Motion in a plane. Yeah, I cross I is 0, j cross j is 0, k cross k is 0. Same way v cross v is lying on the same direction, so that is 0. So, this v cross v is going to be 0 plus, and of course, we know rate of change of momentum is force. So, therefore, r cross f, and this is 0. So, therefore, dl vector by dt is equal to 0 plus r cross f. Children, what is r cross f? We have seen now what is r cross f. R cross f is torque. So, therefore, you can write here dl vector by dt vector, dl vector by dt is equal to r cross f, which is tau. So, torque tau is equal to dl by dt. That is the relation between torque and angular momentum. If tau is equal to 0, therefore, L will be equal to constant, or I can say that L is equal to mv is equal to constant. So, V is equal to constant. So, therefore, you can say that entire body, rigid body is undergoing motion. Therefore, the V at the center of mass about its axis of rotation remains constant over here. So, hope you understand till this, children. So, now how to find out the direction of, how to find out torque, mathematically. So, now suppose for example, I am giving you one sum. So, if r vector is equal to 2i plus 3j plus 2k, and then f vector is equal to I minus j plus 3k, then find r cross f, that is nothing but torque. Torque is asked to find out. So, now box product rule, we have already discussed the same thing. First write plus I minus j and plus k. Now, what you should do here, r cross f, magnitude of I cap 2, magnitude of j cap 3, magnitude of k cap 2, f 1 minus 1 plus 3. Now, when you are going to multiply I cap into this row and this column, forget, then multiply. What is 3 3s are 9? 3 3s are 9, no, so write down minus 1 into 2, how much is that? Minus 2. So, it become plus 2. Then next is minus j. So, therefore, I am going to rub this one I am going to rub, okay, because next I am going to take minus j cap. So, when you take minus j cap, forget this row and column. After forgetting this row and column here, okay, after forgetting this row and column here, now you can write here minus j into 2 into 3, 6, minus 2 into 1, 2. Next, the last one, plus k cap. Now, when you take plus k cap, forget this column and the row. Now, what you get? We get k cap into, I have forgotten that, so 2 into minus 1 and 1 into 3. What is 2 into minus 1? Minus 2, minus 3. So, therefore, 11 j cap, 6 minus 2 is 4, minus 4 j cap, 11 I cap minus 4 j cap minus 5 k cap. So, this is the final answer for torque. So, hope you understand this final answer for torque. So, learn angular momentum and the torque. So, that is very easy for you to learn, and also keep in mind that torque is a vector quantity. When you rotate anti-clockwise direction, it is moving upwards, taken to be positive. Rotate clockwise direction, moving inwards, taken to be negative. So, you can use right hand screw rule, right-handed screw rule to find out the direction of torque. Right-handed screw rule. How to find out the direction of the torque? So, now let us take screw, bolt and the nut. So, when it is rotating clockwise direction, if it rotated clockwise direction, so clockwise when it goes, clockwise, how the clock goes in a house? Whether the clock goes 12 to 3, 3 to 6, 6 to 9 or 12 to 9, 9 to 6. So, it goes 12 to 3, 3 to 6 and so this is called clockwise. See here, is it clockwise? Yes. Clockwise, where does the screw goes? grows inwards. So therefore perpendicular inwards. So torque is acting perpendicular inwards. So which is taken as, this is clockwise, minus direction, negative you have to take. So minus k cap into the plane of the paper. Z axis. So into the plane of the paper. Into the plane of the paper you take it as z axis, negative z axis. It is going negative z axis. Okay. So into the plane of the paper, so you have to take this as negative z axis. But at the same time, if it is going to be anti-clockwise direction, if it is going to be turned as an anti-clockwise direction, then what happens? Now only I have showed you, right? So it is taken, rotated anti-clockwise direction. What is happening? Anti-clockwise direction, what's happening? Is it coming outwards? Yes, that is taken as positive. So this anti-clockwise direction, you take it as positive. So torque is perpendicular outwards. So hope you understand how to find out the direction of the torque. Children, the rest of the part of the lesson, let us see very quickly. That is very easy. Hereafter you can just learn with ease. Okay, so now let us see that. Next, what is the relation? What is rotational kinetic energy and moment of inertia? Rotational kinetic energy and moment of inertia. What is that moment of inertia means? In rotational motion, the inertia accompanied with each and every particle, you call it as rotational motion inertia. That's otherwise called as rotational inertia, or you call it as moment of inertia of a rigid body. Rigid body. So how do you define this rotational inertia or moment of inertia of a rigid body? We will see that. Yeah, I will give you the moment of inertia of a rigid body definition. It is the sum of the product of mass of all particles. For example, here I have taken the rigid body. Lot of particles are present. M1 is present here, M2 is present here, M3 is present here, etc., etc. Mn is present here, everywhere. It is at a distance r1 from the axis of rotation of the rigid body. It is a distance r2 from the axis of rotation of the rigid body. Children, hereafter you take the rigid body only this shape, because I have already told you rigid body need not be a regular shape. A lot of particles are distributed, I have taken like that. So what is moment of inertia of a rigid body? It is defined as the product of all masses and square of distance from the distance of separation of all particles from the axis of rotation. Product of all masses of particles, all product of sum of all mass of particles. So you should say product of sum of all mass of particles, sum of all masses of particles, and square of their distance, square of the distances from the axis of rotation, So it is denoted by I, that is nothing but m1 r1 square, product of sum of all mass of particles. So you have to sum up products of mass of particles. You have to say, put it in other way around. You have to say the sum of the products of mass of the particles. Sum of the products of, so let me just change it, sum of the products of all mass of the particles. Instead of saying here, you can say here sum of products of all masses of particles. You got it? That is how you put the sentence. So sum of products of all mass of the particles. See m1 r1 square plus m2 r2 square plus etc. mn rn square. Considering all masses equal, so I can write it as capital M. What is capital M? Capital M is the mass of the whole body. So m into Ri square, you can write it as sigma I is equal to 1 to n. Or you can even write it as, I don't want to write it in terms of capital M. You want to write it in terms of small m, you write sigma I is equal to 1 to n mi Ri square. That is moment of inertia of the whole body. So how do you define moment of inertia of the body? It is nothing but mass, product of mass and square of distance from the axis of rotation. But it is for the individual particle. Then for all the particles, you add all these products, sum of the products of all masses and their square of the distance from the axis of rotation. So that is the moment of inertia of the rigid body. So now what does it depend upon? Depends upon axis of rotation, depend upon definitely axis of rotation, depends upon actually distribution of mass, axis of rotation, definitely distribution of mass it depends upon. So let me write distribution of mass, distribution of mass, distribution of masses from the axis of rotation, and next distance of the body from the axis of the rotation, distance, their distances from the axis of rotation. So let me show you. So this is the moment of inertia basic. So I haven't come to the rotational kinetic energy. So now let me just proceed the same thing. Total kinetic energy of all bodies can be written as half into m1 v1 square plus half into m2 v2 square plus etc. half into m1 vn square. Now considering all masses equal, so therefore I am going to take this as half into m v1 square plus etc. vn square. But we already learnt v is equal to r omega. See here, v is equal to r omega we have learnt. Where? Here. Yeah, v is equal to r omega. So therefore I am taking this v is equal to r omega here. So therefore half into m into r1 square omega plus r2 square omega, because v is equal to r omega. Since v is equal to r omega here, we take it like that, plus etc. rn square omega. Take omega outside, children, half omega, you took it out, r1 square plus etc. rn square. But I have to consider n particles. I have taken only one particle because only one mass. So by considering all n particles, into account, when you consider all particles into account, multiply and divide by n. So when you multiply and divide by n, you get half into mn into omega r1 square plus r2 square plus etc. rn square divided by n. Okay, children? So this can be written as half into capital M into omega, the whole thing. Differently I am writing the whole thing. Can you check? This is called as k square. What is k square? R1 square is distance of the mass m1 from the axis of rotation. What is R2 square? What is R2? Distance of the particle m2 from the axis of rotation. What is R3? Distance of the particle R3 from the axis of rotation. Similarly, what is k? Distance of the center of mass particle to the axis of rotation. So k is otherwise called as radius of gyration. What is that? Radius of gyration. What do you mean by radius of gyration? That is nothing but mean square distance. Individual distance, you know, we have to find out the mean square distance. So mean square distance of all the particles about its center of mass from the axis of rotation. So therefore you can say that half into mk square into omega. This mk square you call it as moment of inertia about its center of mass. I center of mass equal to mk square. So therefore this is called as rotational kinetic energy. Rotational kinetic energy is simply called as half into I into omega square. That is all. So two things, two in one we have learnt. One is radius of gyration, another is rotational kinetic energy. So rotational kinetic energy is finally half I omega square, and also moment of inertia about its center of mass to be written as mk square, and where m is all the masses, center of mass. So where k is called as radius of gyration. Radius of gyration, that is distance from the center of mass to the axis of rotation. So radius of gyration is equal to k square is equal to r1 square plus r2 square plus etc. rn square by n. So therefore k is equal to square root of r1 square plus r2 square plus rn square divided by n. Root mean square value of all the particles. So that is all, children. So the rest of the part we will learn in the next class. Thank you, children, and then keep studying and then learn by writing so that you will have a clarity of understanding.